Okay, we're going to have a look and at this Tektronix 1S2 sampling unit again. I want to have a look and see if there's anything coming out of the internal pulsar, for which I'm going to use this device here. This is a Tektronix 7912 digitizer. It's basically an analog scope with a bandwidth of about 700 megahertz with a scan converter on it connected to this TV up here. And I will use this GR874 to BNC adapter into the pulsar output here, like so, and connect that up with a cable to the 7912, and let's see if we get anything out. If we connect that to the internal pulse source. Trigger source internal. Oh, it seems to be triggering. The graticule's brightened up. Let's adjust that. Have we got anything we can see? Not a lot. Crank up the intensity. Not to be seen there. Oh, wow, there is something. There is something. Let's turn that down a bit. We have. This is supposed to be 1 volt peak to peak, I think. A rise time of a nanosecond, according to the specs. That's very pleasing. We've got something there. It's a bit short of 1 volt, but then none of this is very accurately calibrated. And let's move the position around a bit. So 10% to 90% thing is pretty much a nanosecond. That's very pleasing. So that's working as it should. We have a pulse output. Let's have a look at it a bit further out. Fiddle with the intensity a lot on this thing. What's the repetition rate? Slow it down to the microsecond. Oh, there we go. Look. Aha. Push button time base is not very friendly. Okay, so there we go. Look, that's 5 microseconds per division. And we get. That's about 15 microseconds per cycle, isn't it? So 60 kilohertz or thereabouts. Does it change with any of these? 10 meters. Okay, it slows down when you set the range to a kilometer, not surprisingly. What is it then? That's more like 60 microseconds per cycle. So it slows down a bit. Okay, well that's that one. That's good. Let's go back to the more frequent one. So let's have a look at the other pulsar, which I think is supposed to be like no, it says here 0.25 volts, 50 picoseconds rise time. Well, we won't be able to check the rise time on this scope because it's too slow. If we set that to that. Oh, we have something, look at that. A bit bigger, so it should be 50 millivolts. Oop, no, 0.25 volts. That's looks a bit small, to be honest. Yeah, not everything it should be. We've got a dodgy connector. We've got a dodgy connector. Oh, good is it? Which is dodgy? Is it my BNC connector or is it the? No, if I hold that, that's more like 0.25 microsecond, 0.25 volts, isn't it? And let's speed things up a bit. Let's see if it's. See what the rise time's like. Oh, that's really fast. That is. I mean, this is the rise time of the scope is about 600 picoseconds, but that is quick, properly quick. That's the right limit of the scope. So that is definitely a fast pulse, even if it's a bit dodgy and wiggly. Excellent. Does that one change in frequency as well? Turn that 500 microseconds. So that's like that. That's a 20 microseconds per division, so we've got about a pulse of every 15 microseconds. Does it change when we change ranges? Yes, it does, the same way as the other one does. So we have pulsar output of this, which is very nice. Just out of curiosity, I wonder if it's my cable and adapter that's dodgy, or whether it's the socket. Let's have a look at the other one and see if we can get the amplitude back to 1 volt the way it should be. Now that one's not got a dodgy connection. That one's much happier. That is more or less 1 volt. It's got its friend down here somehow. Oops. Yeah, that just needs something funny going on in the connector. But the 1S2 is not entirely dead. It does produce output. Now we could have a look, see if there's any sweep output coming from it. I put the fat probe in here and have a look. Vertical output. What have we got there? So there's 1 volt per division, so we should have put this on like 2 volts per centimetre. Let's trigger it like that. Oh. It's not great DC stuff, this thing. Vertical output. Oh, there's something there, look. Not sure what. Horizontal output should be a ramp, I'd have thought, but on manual mode, no, it doesn't. Doesn't change the way I'd expect. So something is broken about the sampler and it's sweeping, but the pulsar works. That's all right. Cope with that.